Okay, 6.5 in your textbook is on division of fractions. In last class, we talked about two methods to find the answer to a division. So what we're going to do is we're going to start with an example. And the example that we use in your show, you know, is 4/5 divided by 3/10. Now, before we actually get to the division of this, I'm going to first teach you how to estimate this using money cents. So to estimate, all you have to be able to do is, the two skills you need is number one, you have to be able to turn a fraction into a decimal. The first skill you need. And the second skill you need is being able to think about that decimal as money. So what do I mean by that? Well, let's look at this first question. 4/5 divided by 3/10. Now, 4/5, if I'm thinking what is 4/5 as a decimal, you learned back in grade 7 that if you make a fraction into an equivalent fraction out of 10, 100, or 1,000, so in this case, the equivalent fraction to that is this number. And if I read this fraction as being 8/10, and when I go to write my place value, this is the tenths, this is the hundredths, this is the thousandths, this is the 10,000, etc. So 8/10 would be an 8 in the 10th position, and therefore would be 0.08. So 4/5 is a decimal, is 0.8, and 3/10 is 0.3 because that's what 3/10 actually looks like. So now I have to say, so that's the first thing, is changing the fraction into decimal. And the second part says think of it as money. So the first part is how much money you have. So I have 80 cents. And I have to divide that 80 cents into piles of 30 cents. So I have 80 cents. I'm dividing it into piles of 30 cents. How many piles can I make? Well, I can make 2 piles and a little bit left and a little bit more. Or to translate that into a decimal, 2 decimal something. Or as a mixed fraction, 2 and so many fraction. All right. So my estimation to this question is using those skills, thinking about money and realizing that my answer will be 2 decimal something. So I'm going to write that down. My estimation will be between 2 and 3. That's my estimate. So the two ways you can use it, there's two ways you can actually find the answer to this question. The first one is what's called finding a common denominator. A common denominator method. Again, as you're going through this video, if you're watching it and you don't have these as notes, you can pause this video at any time, stop listening to me, copy down the notes, and then you can use this as an exemplar for solving other questions that are just like it. So the common denominator method is one. So if I take these two fractions and I find common denominators, in this case, what is the common denominator for 4/5 and 3/10? Well, the first thing I need to do is find the first multiple that 10 and 5 share. And the first one they share is 10. So that's what we call the lowest common denominator. We could use that as a common denominator. We could also use 20. It's not the lowest, but it is a common denominator. We could also use 30, 40, 50, 60, etc. So because we know that 10 is the common denominator, I'm going to rewrite both of these fractions, making equivalent fractions that have 10 as a denominator. Well, 3/10 doesn't change. It stays as 3/10. But 4/5, as we did in the first example, as an equivalent fraction, is 8/10. So now that we have it written like that, we're going to say, okay, 8/10 divided by 3/10. If I use the same process for multiplication, meaning divide the numerators and divide the denominators, I will end up for sure, because we have a common denominator, every time I will end up with a common denominator of 1, or a simplified denominator of 1. And we all know that when we think about that, we can think of it as being a denominator of 1 or dividing by 1. And in either case, it is not necessary to write something over 1, so it's actually superfluous, or it's not necessary. So the top part, 8 divided by 3, if I think about what does 8 divided by 3 mean, well, I could think of it either as division, but I can also think of it as a fraction. So technically, I can think of it as a decimal or as a fraction. So if I thought of it as a decimal, I would go, what is 8 divided by 3? And I press the equals button and say 2.6 repeating. But instead, I'm not going to think of it as decimal. I'm going to think of it as an improper fraction or as a fraction. And I'm going to actually keep it as 8 over 3. So it's 8 over 3 is the numerator. The denominator is 1. Since denominators of 1 are not necessary, I simply have my numerator as an answer, which is 8/3. Okay? Because dividing by 1 doesn't change it, so I just have my numerator as my answer. 8/3 is an improper fraction. As a mixed fraction, it would be 2 and 2/3. So my answer to what is 4/5 divided by 3/10, my answer is 2 and 2/3. Now remember, my estimation was some number between 2 and 3. And 2 and 2/3 is between 2 and 3. So my estimation process worked. And my answer, using this common denominator method, seems legit. Seems like it worked. But there is a different way you can do it too. The second method. The second method to solve this would be what we call multiplication. We'll call it multiplication. Multiplication by reciprocal. Reciprocal. Oh my God, reciprocal. Now, reciprocal is a fancy mathematical word for simply flipping a fraction upside down or exchanging the numerator and denominator of a fraction. Flipping a fraction. So what does that mean? Well, if I go back to my original question of 4/5 divided by 3/10, in order to get the same answer, you can always get the same answer by keeping the first fraction as is. Do not flip the first fraction. Keep it. Change your multiplication or your division symbol to multiplication. So change this division symbol to multiplication and use the flip of the second fraction. So the first fraction was 3/10. Therefore, its reciprocal, if I switch the numerator and denominator, would be 10/3. Okay, now watch this. So when I change the second fraction to its reciprocal and change division to multiplication, now when I multiply the numerators and multiply the denominators, oh, sorry, that's a 3, I get 40 over 8. Is that right? No, that's not right. 40 over 15. Oopsie daisy. That's a 3 there. 40 over 15, which is 2. Because how many 15s are there in 40? There's 2. That's 30. And 10/15ths left over. 10/15ths is not lowest terms, but when I reduce it to lowest terms by dividing both by 5, because I end up with 2 and 2/3. So it worked. I got the same answer. But instead of finding a common denominator, I simply multiplied by the reciprocal. And these two methods will work for any division of fraction question you can encounter. Okay? So let's see if we can try a different question, see if this works. So the second show on the sheet was 2/9 divided by 5/6. So the first thing let's do, let's just estimate first. So I'm going to say, well, what is 2/9 as a decimal? So I'm going to take my calculator, go, it's 2 divided by 9. It's 0.2 repeating, so it's approximately, I'm just going to make it 20 cents. It's actually 22 cents, but we'll make it 20 cents. Divided into piles of whatever 5 divided by 6 is. So 5 divided by 6 is 0.83, so I'm going to make it roughly 80 cents. So remember, this is the amount of money you have. I have 20 cents, and I'm required to divide it into piles that are 80 cents big. But I only have 20 cents, and I have to make a pile of 80 cents. So we know we can't make a pile because we only have 20 cents. But how much of a pile can we make? Well, if I have 20 cents and my pile needs to be 80 cents big, I can make a quarter of a pile. So my estimation is going to be a quarter. I can make a quarter of a pile if I have 20 cents and I have to make it 80 cents big. That kind of makes sense. So the estimation for this is going to be a quarter using my money cents. The first method is to find a common denominator. If I think about 9 and 6, what's the first multiple they share? It's 9, 18, 27, 36. It's 6, 12, 18, 24, 30, 36. The first multiple they share is 18. So 18 would be my lowest common denominator. I could also use 36 if I wanted to. The only difference would be I'd have to reduce my fraction. So 18 is the lowest common denominator and therefore the easiest number to work with. So I put 18 over 18. The equivalent fraction to 2/9 is 4/18. The equivalent fraction to 5/6 is 15/18. I'll erase this stuff here. So now that we have that, we're going to divide our numerators. 4 divided by 15 over 18 divided by 18. Remember, whenever you have 18 divided by 18, you have 1, which is really, well, I'll keep it there. It's going to be gone in a second. But 4 divided by 15, I'm not going to change it to a decimal. I'm going to leave it as 4 divided by 15. Since dividing by 1 doesn't affect it, I end up with 4/15 as my answer. Now, looking at your estimation of a quarter, does this seem reasonable? Well, it does, because 4/15 is pretty close to 4/16, which would have been a quarter. So therefore, the answer of 4/15 makes sense according to my estimation. The second method you could have used here would be the multiplication by reciprocal. So keep your first fraction, change this division, change the division to multiplication, and use the reciprocal of the second fraction. So the second fraction was 5 over 6. The flip, or the reciprocal, will be 6 over 5. And now that you have it rewritten as this equation, multiplication is so easy. You can multiply your numerators to get 12, multiply your denominators to get 45. The only problem with this is a lot of people look at 12/45 and think it's lowest terms. But remember your divisibility by 3 rule. If you take 12 and you take the digits and add them together, you get the number 3, which means 12 is divisible by 3 because the sum of the digits is a multiple of 3, so therefore 12 is divisible. If I take 45 and add those digits together, get 9. 9 is also a multiple of 3, so 45 is divisible by 3. Therefore, I take this, I divide it both by 3, and divide by 3. I get 4 over 15, which is the answer I got up here, only in lowest terms. Now, alternatively, you could have divided through cross reduction. 6 over 9. If I thought about what 6/9 was, I could reduce that to lowest terms by being 2 over 3. So I could have actually reduced 6 over 9 to lowest terms, which would have been 2 over 3. And when I multiplied my new numerators, I would have got 4. When I multiplied my new denominators, I would have got 15. Reducing before you multiply as opposed to after. And your last question in the show, you know, gives you a mixed fraction. So this time it's 3 1/6 divided by 1 2/3. So let's do our estimation first. 3 1/6. Well, 1/6 is 1 divided by 6. So 1/6 is roughly 16 cents. So we're going to call this one $3.20. We're going to round to the nearest dime, I suppose. So instead of $3.16 repeating, it's going to be that. Divided by, well, what's 2/3? So 2 divided by 3. Change that fraction part to a decimal. Decimal 6 repeating. Let's just make that, well, you know what? I could see something easier. I'm going to go 1.60 here. All right. So if I think about money, this is the money I have. This is the money I'm going to make piles of. So I have $3.20. I'm going to make piles that are $1.60 in size. If I have $3.20 and I'm making piles of coins that are $1.60, my estimation is approximately 2 piles, because I can make 2 piles with $3.20 if each of the piles is $1.60 high. So my estimation for this is going to be roughly 2. Not exactly, but it's an estimation. Now, if we're going to use the common denominator method, I cannot use mixed fractions. So what I have to do is I have to first start by changing both of these fractions into what we call improper. Now remember, if you ask the method for how to change a mixed fraction improper, of course, this 3 here is really made up of, let me just show you, 1, 2, 3, 4, 5, 6, 6, 1, 2, 3, 4, 5, 6, 6, and 1, 2, 3, 4, 5, 6, 6. So that 3 for that whole number is really 18/6. There's 6 here, 6 here, and 6 here. There's 18/6 that make up that 3, plus an additional 1/6 right here. Let me backtrack here. So that 3 1/6 is really 19/6. That 1 2/3, if I draw it here just to show you again, there's 1, and an additional 2/3. So 1 2/3 is really, well, this is 3/3 plus an additional 2/3, or 3 times 1 is 3/3 plus an additional 2/3 is 5/3. So 1 2/3 as an improper fraction is 5/3. And now that we have it written like this, now we're going to use both of our methods. The first one, common denominator, and the second one, multiplication by the reciprocal. So our common denominator we're going to use here is 6, because it's the first multiple 6 and 3 share. 19/6 will not change, but 5/3 is equal to how many sixths? The answer is it's 10/6. Now, divide your numerators, divide your denominators. Change this division not to a decimal but a fraction, divided by 1. Think of 19/10 by itself as an improper, and your answer will be 1 9/10. That is the solution. Go back to our estimation. Our estimation of 2 was pretty freaking close. That's a good guess. Our answer is 1 9/10. Alternatively, no, not 16/6 divided by 1 2/3. If I use the other method, which is multiplication by the reciprocal, you cannot multiply by the reciprocal of a mixed fraction. You must look at that fraction first as an improper. So again, I'm going to change these over to improper fractions rather than mixed. And then I'm going to simply keep the first fraction. It's not going to change. Change the division to multiplication and use the reciprocal of the second fraction. So instead of be 5/3, I'm going to flip the numerator denominator or use its reciprocal, which is 3/5. Now a smart person right here would cross reduce. So I'm going to cross reduce first. If I think of this 3 and this 6 as being a fraction, in lowest terms, that will be 1/2. And when I multiply that out, 19 times 1 is 19. And 2 times 5 is 10. And because I got that, I got the exact same answer above it. Now, if you didn't cross reduce, it ain't no thing, because all you have to do is multiply 19 by 3 and 6 by 5. 9 times 3 is 30, 57. 57 over 30. Both are divisible by 3. Remember, 5 plus 7 is 12. 12 is divisible by 3. So therefore, this is as well. 30 we know is divisible by 3. So take my calculator and say, what is 57 divided by 3? It's 19. Hang on, 57 divided by 3 is 19. Over 30 divided by 3, which is 10. And I still get that same answer as 1 9/10.